All right, I think we are live. Welcome everyone to the second Azure Cache for Redis community stand-up in July 2023. This week we'll be focused on using Azure Cache for Redis with Azure Functions, which is a really exciting topic. I want to mention real quick before we start that there's some links there in the bottom right if you want to get in touch with us. We're always happy to hear from customers and fellow devs. We have our email and our Twitter, or is it X link now, to Azure at Azure Redis. And then our past calls available in the top link there for the Redis community calls. All right, let's dive in. And there we go. And good morning, good evening, good afternoon to wherever you are. We're glad you're here. A few things to start out with. One is if you have any questions, ask them in the chat. We have people here to help with the chat, and we can address those questions live here on air as well. So always excited to hear about questions. And then, like I mentioned, please feel free to reach out to us at that email address. We always love hearing from folks. All right, with that, let us dive in. So first, just a quick background on Redis. Maybe most people here know what Redis is, but in case you don't, it is an open source, in-memory, key value, NoSQL data store. There's a lot of mouthful there, but what that really means in practice is that it's open source, so it's widely used. It's really secure and well known. It's in memory, so it's very fast and scales very well. Key value means Redis is quite straightforward to use and easy to learn, although it's also much more powerful, as you will learn. And then it's a NoSQL data store, and like many NoSQL data stores, it's designed to scale both vertically and horizontally. And so it's kind of designed for more cloud native workloads that need cloud levels of scale and speed. All right. Basic example of what Redis looks like. You can set keys and values and then get those values back when you ask for the key. So in this case, set the key, the value, the key is key and the value is hello world. When you request the key, you get hello world back. So that is the most basic form of Redis. It's not too hard. People use Redis for really three main reasons. First is speed. Like I mentioned, it's all in memory, so it's really fast, down to sub-millisecond latencies. Second is scale. Like I said, it's NoSQL, so you can scale out really easily, and you can get just massive multi-millions of requests per second of throughput. And then simplicity. All right, so it's key value design. Even the expansions upon Redis to make it more powerful and advanced are still quite simple compared to other databases. And so a lot of benefits there. The result of this is that Redis has been the most loved database in the annual Stack Overflow survey for 5 years in a row. That streak actually was broken last year. Postgres just barely beat out Redis. Redis was number 2, but it's still right up there. So we'll see what happens in 2024. All right, there's a bunch of use cases for Redis, and many of you listening to this probably know a lot of these use cases, are familiar with them. The big three are as a just kind of basic cache, usually in front of a database. It's a way to accelerate an application, make it run faster. The most fastest growing use case is more as a data store. So a great example of this is like a shopping cart. I'll dive into some more detail there, but basically just a temporary or ephemeral store of data. And then the final is for messaging and streams. And that one's growing really fast too. So things like PubSub, and there's a function in Redis called streams, which is kind of like Kafka in a lot of ways. And there's some really specific examples you listed there too. Things like vector similarity search are becoming more and more popular, and Redis is really well positioned for that. And there's a few other use cases there as well. And so feel free to look through those, and we have more documentation online about some of those specifics. But the upshot here is that Redis is very flexible, it's very powerful, and growing in use because of its flexibility and power. All right, well, let's get down to functions, which is the topic for today. So if you're not familiar with Azure Functions, it's a really useful serverless tool on Azure. And there's 2 types of integrations for services with Azure Functions, right? So functions themselves, serverless, you execute kind of a snippet of code on demand, or based on a certain time structure, which allows for these really new and exciting serverless architectures. There's really 2 types of integrations with Azure Functions: triggers and bindings. So triggers, when you think about it, it's a way to evoke a new function execution. So something happens on my cache, and that triggers this new serverless function. And then the second is bindings. And bindings are basically easy ways to get data in and out of another Azure service. There's a whole pile of Azure services that support these integrations with functions. That list is growing. And the newest addition to that list, I'm pleased to say, is Azure Cache for Redis. So we now in preview have a trigger support for Azure Functions. And we support a whole pile of triggers. So you can trigger on pub sub channels in Redis, on lists, on streams, on key space and key event notifications through the pub sub trigger. And we support a variety of languages. So from maybe your friendly C# or like me, you prefer Python. We support kind of the whole gambit of the most popular languages. And right now we support premium and durable functions. We'll support consumption functions soon, but not quite yet. So what can you actually trigger on? Well, so I think this is where Redis and functions are really special because you can trigger on a huge variety of things. So for instance, I mentioned PubSub being a use case for Redis, where people will use Redis as an intermediary between maybe users and microservices, or even just different microservices on an application, where one microservice can send a message to Redis. Redis publishes that message to all other services listening. And so you can use this for a whole bunch of different applications, but you can use functions to listen in on those channels. And so when a message is published, a status update or instruction or unlocking functionality, you can trigger a function based on that and do actions or move things on to the next phase. I won't go through all of these, but just to go through a few highlights, there's extensive functionality with Redis lists and streams. And streams in particular is useful because that's a more durable data type in Redis to handle messages. So great for communication and coordination between services. You can trigger on things like new keys or expired keys. And that's really useful, as I'll talk about later, to maintain consistency between your cache and applications or databases. And same thing with new values, right? If you set a new value in Redis, that's awesome. You can use that to trigger a function with that new value in mind. And so, like I said, there's many of these different functions and activities on Redis you can trigger on, and that makes this really powerful and flexible for your application and your use case. And the goal from our end is basically to make your life as a developer easier using functions with Redis as a way to connect pieces of your application together. Redis is such a critical part of many applications that the problems we mainly hear aren't with Redis, it's with how do we connect Redis with our application or with our database? How do we change the structure of data? Functions can be that intermediary layer to make that much more straightforward and simple. Okay, so let me go into a little more depth about what this looks like in the real world. So this architecture I have here is a really common application we see with Azure Cache for Redis. It's called a cache aside or sometimes a side cache architecture, where you have an app, maybe it's through app service or Kubernetes or Spring Apps on Azure, or maybe just API management. So I'll call it all kind of a backend application. And that application talks to a database. Well, in the perfect place, your database would be fast enough and scale enough that you wouldn't need a cache. But in practice, in a lot of applications, it helps a lot to have a caching layer in between the app and the database. And this makes things much faster, right? You can use that cache to handle higher throughputs. You can provision a smaller database instance and save money because the cache is handling a lot of that traffic. And it lowers latency, right? It increases performance, website load times, backend performance. So a lot of benefits from using a cache. And this is very common in our customers and around Azure. But there's a couple of challenges with this application. So the first challenge is, how do you load the cache with values from the database? We'll talk about what that looks like. Challenge number two is, how do you keep the values that are already in the cache fresh? What if there's some stuff in the database that's changing? How does that reflect it in the cache? And how do you ensure that the cache has the latest non-stale values? And then the third thing is, how do you handle heavy write scenarios, right? You see in this use case, cache is being used as kind of a read-heavy replica of the database, which is great. But what if you have a heavy write workload? How do you prevent that heavy write workload from overwhelming your database? Well, functions can actually solve all three of these problems really elegantly. I'm going to walk through each one. So the first is what's called a read-through cache. And this solves that first problem of how do you load the cache. So the most common method that's used here is called lazy loading, where basically the application requests the data from the cache first. And if the data is not in the cache, you go to the database and then you load the cache with the data that you requested that wasn't there. So basically every time there's a cache miss, you load the cache so that in the future, the data is right there. So this is one of the simplest ways of doing it. It's quite effective, but in past, it's required your application to be more aware of what's in the cache and what's in the database and managing the relationship between those. With the functions integration, you actually can kind of drop that application piece from this. And in this case, what we're doing is we're actually triggering on a cache miss event. So it's just in the cache triggering a function. When that miss event occurs, your function is triggered and it pulls the missed key from the database. And then the function itself writes that value back to the cache. So in this case, you take your app service instance or your Kubernetes instance completely out of the equation and just allow your cache and your function to manage the values between the cache and the database. It's much more straightforward this way. It's also really fast. The second use case is with consistency, right? So this is the problem of stale data. And this is like a classic problem in architecture on the cloud. I think this is actually a classic computer science problem, but don't quote me on that. The advantage here is there's actually built-in expiration functionality into Redis. And so you can set keys to expire after a certain amount of time. So in this case, let's say we've set the keys in our cache to expire after 5 minutes. When that happens, that actually can trigger a function. So every time your key expires, it triggers a function, and that function can then pull the appropriate data from your database to make sure the value is fresh. So you basically have this self-perpetuating loop that perpetually refreshes the data in your cache. And you can configure how often that occurs. If you want to refresh some keys, every 10 seconds, you can do that, and some keys every 10 days, you can do that. And so there's a lot of flexibility here on a key by key or data set by data set basis to maintain the consistency that you need without having to constantly query a database or constantly querying a cache. And so this can save money too, right? Because you can be flexible. You can have a database instance, like a Postgres instance, that isn't over provisioned. And that's really helpful. All right, the third example is a write behind cache. And this means that you're basically just writing to the cache rather than writing new values to the database. And so there's a lot of advantages of this approach. One is that it's a little more convenient because you can just run through the cache all the time for reads and writes. And the second is that Redis is really better at handling high throughputs. So if there's a bunch of writes, Redis is going to be a better place to dump those writes, especially if they happen all at once, than your database. And so in this case, you write all your routes through Redis. Every time there's a new value, that function is triggered or can be triggered periodically as you like. And then the function will write those values to the database. So again, a really convenient way to handle some bursty or high write workloads. Okay, so this is the basics. Let's hop into a demo, if I can share my screen, and we'll talk and show you a little bit about what this looks like in practice. All right, let me share my screen. All right, it's coming up. Okay, here we go. So right here we have our demo, and there's three pieces to this. I'm using Cosmos DB as the database in this case, and I have my function and my Redis instance. And so what I got going on here is a function. As soon as this comes up, the internet slows down when using our streaming platform, so bear with me as this might take a little bit. All right, it's loading. Okay, so I'll scroll down here. So you see we have two functions. One is a write behind, and the other one is a read through. And so what this is going to be doing is every time I write a value to Redis, it's going to write that value to Cosmos. And then if I request a value from Redis and it's not there, it'll pull Cosmos to see if the value exists there. And if it does, it'll pull that value into Redis. So what I'm going to do here is the function's already running. I'm going to start the logs just so we can see what's going on. All right. Okay, so we're connecting there. I'll let that continue. So this is my Redis instance, and then here is my Cosmos instance. You'll notice that there are currently no values in our Cosmos DB right now. All right, yeah, this is all running kind of slow. Okay, so what I'll do is I'll open up the handy built-in console within Redis. So this is a feature of Azure Cache Redis. You have a built-in Redis console, which is really convenient for situations like this. And I'll go ahead and set a few values. So we're going to pretend this is like an inventory system for a supermarket website. So I'll set values. I'll get our produce. We'll say apples are costing $4.25. They're expensive organic apples. So they're expensive. We'll look at some bread that's going to be on sale. It's $1.25. And then we'll say that bananas are $10. All right, so we got those values set. Let's go back to our Cosmos container and refresh. And we should see that we have these values now stored within Cosmos. Let me see if I can click on one and have it come up. Yeah, so here we go. Bread, we have our key of bread, or there's apple. Key of apple, the value of $4.25. So we automatically loaded all of this into Cosmos, which is pretty useful. But here's the really fun thing. If we go back to Redis and we clear our cache, I'll just flush our entire cache. And you can see if I check our keys, we got nothing in it. So I've emptied our cache completely. What happens now if I request one of these values? Well, so you'll see if I say, all right, let's get apple, PPLE, it's going to say, oh, apple does not exist. And that obviously is a cache miss, right? It's not in the cache. That makes sense. But if I do it one more time, it gives me the value, 425. And that's because if we go to our logs, we see all of this occur. So we see our logs from our new values being added to Cosmos DB. And then if I can scroll down, we can see that as I'm requesting the key, it detects that key miss and actually adds that value to Redis. So I have it now in the future. And this actually works for all of these values, right? So if I do a scan 0 again, you see I have just the apple key added. So if I say get bread, again, it will tell me nothing, but if I look, oh, I have that key added. So if I do get bread again, boom, I get the value. So this is a really cool way to see how Redis can handle, Redis and functions in particular can handle the kind of bidirectional data synchronization that you would need in a real world application, where this makes it much easier to communicate back to Cosmos and also much easier to handle when data goes missing or data expires, because I can just pull it automatically from a database. And so the goal here is to make your life easier as a developer and kind of make that coordination easier. Okay, cool. All right, let me run back to my slides. Okay. And share on the stream. There we go. Okay. We are back to the slides. All right, one more architecture I wanted to mention. I don't have a demo for this, but also a really powerful use case for Redis and functions, which is more event-based architectures. So example here, again, kind of a retail example is you might have a AKS cluster with multiple different microservices. So storefront, maybe a billing service and a supply chain or order processing service. And so in this case, instead of having to kind of coordinate between these services, you can use Redis as a queue using the stream type or with PubSub, like I mentioned before, to kind of coordinate between some of these services. And then use the built-in trigger functionality to make that more seamless. So in this case, the flow is you have a user that makes an order to your storefront that adds order information to a Redis stream data type as kind of an order queue. And then that creates a function that then tells different AKS services to run through their processing functionality, billing, supply chain. When those services are done, they might store that order state information back in Redis as another stream on the same stream or just as a key value. And then that can trigger another function to tell other services that the order has been processed. So then you can trigger analytics from Azure Synapse. You can trigger your database as kind of a source of truth. And then you can trigger notification hubs to tell the customer that the order, in fact, was processed. So kind of a cool way to use multiple Azure services combined together in a push configuration rather than a polling configuration, which has, of course, benefits. Okay. So a few caveats here as we wrap things up. One is that this is in preview, and so we're still testing a few things. One thing is Redis can handle a lot of throughput, like I mentioned, millions of requests per second. We're still testing how well functions will scale in some of those use cases, right? If you get 1 million requests in the duration of 1 second, will functions scale fast enough to handle all of those requests? TBD, we're going to do some testing on that and provide some guidance around that. And two is there are opportunities for circular dependencies, right? If you have, for instance, a database like Cosmos or Azure SQL has some function support now too, that create a trigger based on new data, and that trigger adds data to Redis, and then Redis triggers on new data and adds that data to the database. You can create circular dependencies that will just cause a bunch of functions executions. And so you want to monitor that and have some guardrails in place to prevent that from occurring. I think the other thing to mention here is some coming soon information. So right now we're in preview. We plan on GAing in the fall. And before we do that, we'll release bindings, both input and output bindings, and also consumption function support. So what that means is that in the demos that I'm showing, we're using a Redis client to access Redis and read and write data from it. In the future, you can do that natively through the function itself with bindings. And services like Cosmos, for instance, already have those bindings. So it'll be similar experience. And then consumption function support is just being able to run on kind of true serverless functions that like a premium function or a durable function is kind of always provisioned and always running, where consumption functions are more on demand. So we'll support those as well during the GA timeframe. All right. I think that leads us to the end. If you have any questions, please throw those in the chat. We're happy to answer them. And while writing those, if you have questions, I'll just mention that aks.ms link with the latest Redis features. We're always rolling out new features for Redis all the time. We have a recurring series of community stand-ups. This is the second one, as I mentioned. The first one was on Azure Active Directory or Intra ID now support for Azure Cache Redis, which is another great feature. And we'll be doing these about once a month. So please tune in and take a look. And then, as I mentioned before, our email address for our PM team is there. We're always happy to hear from you. And our Twitter/X/whatever it's named tomorrow handle is also there, which is at Azure Redis. So feel free to tweet at us and follow us on Twitter. Fantastic. It looks like there was one question in the chat, and about right behind caching and Postgres. And it looks like that was answered as well in the chat. I should mention that the demo that I shared was done by some of our awesome interns this year, and they're also on the chat, so they may be the ones answering those questions. Kudos to them for a great demo. All right, well, I will wrap things up. And like I said, go ahead and reach out to us on Twitter or on email if you have any questions. And we'll see you next time. Thanks for watching.